Good afternoon, everyone. I'm Wang from National Astronomical Observatories of CAS. I'm on behalf of our group to give this presentation, Radio Science Electron Density Profiles of Lunar Ionosphere based on the surface modular of circulunar return and reentry spacecraft. There are three parts of my presentation. First is introduction to radio science experiments on lunar ionosphere, and the second one is about the data analysis and then the discussion. First, we all know radio science experiments are conducted by the transmitting high-frequency carriers between our spacecraft and the ground stations on Earth. So here is an illustration of the experiments. Well, the propagating the signals are modified as they are influenced by a lot of things. There are the relative motions between the spacecraft and the ground stations. There are particles. There are neutron atmosphere. There are a lot of things influence the signals. If we record the signals and modification of the signal parameters are measured and recorded by the ground station, so we can separate the influence and find out what we want. So if we use a coherent signal, coherent frequency downlink to separate the dispersive from the non-dispersive effects, the influence of charged particles will be easily obtained, and it's also very accurately. There are a lot of radio experiments have been done in history for lunar ionosphere. First is the lunar 19 and 22 missions. It's a Russian mission. They have obtained results here, and there are 7 profiles have been published for these 2 missions, and the result shows the electron density of lunar ionosphere is from 500 to 2,000 cube per centimeter. And ESA also have several radio occultation experiments, including the flyby of Cassini, Venus Express, and also Smart One. But I didn't find any publications of the result. About 10 years ago, there is a Japanese mission, Selene, and they did the radio occultation experiment too, and they have a lot of records and more than 370 observations. They get this density profile, the Coulomb density profile here, but the variation between profiles are so large, and people analyze that, find out there are periodical interference from the rotation of the satellite, and also because there have been done between spacecrafts, and the noise and the signal ratio was low, so the result, they only give 1 electron density profile finally. Oh, sorry. There is also one in situ measurement was done like 40 years ago by Apollo 14, and there is a payload named Charged Particle Lunar Environment Experiments, and the result is like 10,000 at several hundred meters high. So we can see the result between different missions are so obvious. People always doubt is the lunar ionosphere exists or not. It's like 3 years ago, Chinese have a mission, the circulunar return and reentry spacecraft. This one is a Chinese precursor mission for the Chinese lunar sample return mission, and after the return and re-entry experiments, the service module of this spacecraft went back into a lunar orbit for the extension science period. The orbit inclination is 43 degrees and the height of it is 200 kilometers. Onboard this service module, they have X and S coherent signals, and the short-term stability of USO is 10 of the power of -9. This orbit is 3x stabilized, and there are no theoretical influence of this. JAMS and CASH stations join our experiments. After we get observations, first we should extract the carrier phase. This is very important for radio experiment. So our team developed a local correlation process method to extract the frequency and phase. This method is very useful for inhibiting the interference caused by the stability properties of the space-boron crystal oscillators. And use this method, we can conduct the correlation calculation of the received signal and the reference signals. After we get the phase carrier phase, we do the dual frequency phase difference, and then we should eliminate the interference of Earth's atmosphere and ionosphere. For this part, we use the same method with Celine team. We can use the basic idea of it is choosing the proper observation period, which only contains the information from Earth's atmosphere and ionosphere. In this period, the total electron density of Earth's ionosphere and the interplanetary plasma along the site is considered changing linearly in the short time and can be predicted by the polynomial fitting. After that, we got the density profiles here. There are 14 profiles we get from now. The result shows the lunar ionosphere is very obvious, and the maximum of the electron density is near the surface and almost 6 or 7,000 cubic centimeter. And compared to other results, the maximum of the electron Coulomb concentration are between 0.4 to 0.5. Is 2 times of the maximum result from lunar 19 and 22, and 1 or 2 orders higher than Celine result. But this result is well matched with Apollo 14's. This result shows the lunar ionosphere is clearly exists and much stronger than we expect. If we separate the result by solar density angle, we can find out that the largest part is happened in the sunrise and sunset. So in this case, the maximum is around 6,000, but the highest altitude of the ionosphere is around 70 kilometers. In the daytime, and the ionosphere is getting smaller than the morning and the evening. But it's not the difference between between midday time and this part is not very obvious, but we can see the ionosphere is getting higher than sunrise and sunset. So this tells us. Also, I should say that there is also a time gap between this one and this one. We still need more observations to tell us how did this one become to this one. In summary, the maximum of the electron density is more than 3,000, and the new readout is 2 times of maximum readout from lunar 19 and 22, and also 1 or 2 orders higher than Selene readout. This maximum case happened around sunrise and sunset, and also show that lunar ionosphere is obvious. It's not something we don't need to concern. This may be influence our spacecraft landing missions. This also raises a new question. So how did the lunar where did it come from, and what is the characteristic, and how did it form? So we will do more observations to find out that questions. Thank you, everybody.